Hey everybody, I'm Mr. Mills, obviously, and this week we're going to be doing a really brief introduction to the 6 trigonometric functions. These are one of the coolest things in the entire realm of mathematics, and I am super sad that we didn't get to dive into them at all this year. I hope that a lot of you take pre-calculus next year because there is so much that goes on with these things. I'm not doing justice by making this video in terms of I do not at all think that you will know everything about trig in the next week, because that is impossible, because they are so deep and super imaginative, to be honest. It's hard to comprehend them in a short amount of time. So what we're going to do is we're going to take one section and do it for quite a while, much longer than we normally would, because I think that trig functions are super cool. They're one of my favorite things about math. And also, if you've taken physics, or if you will take physics or pre-calculus or anything in engineering, whatever, trig functions are going to be your boy, okay? Now, trig functions, they look kind of like almost made up, but trust me, as Mr. Mills himself, they are not made up, I assure you. We're going to use them with triangles. That's really what they're used for. However, they actually come from circles. Long story. Okay. All right. 6 trig functions. So here's how I'm going to start. I'm going to start by drawing a right triangle. Now, if you remember from, If you remember from geometry, a right triangle is a triangle that has a right angle in it, right? A 90-degree angle is inside that right triangle. Okay. Now what I'm going to go ahead and do is I'm going to label each side of this triangle with a measurement, right? Let's say this has length 3, 4, and 5. Okay, this is 3 units, 4 units, and 5 units. Okay, that's totally fine. Now what I'm going to do is I'm going to introduce the Greek letter theta. Theta looks like basically a 0 or a circle with a line through it. Honestly, it looks like a Pokeball, right? That's theta. Hi, theta, okay? Greek letter theta, super cool. Usually theta is used when we're talking about trigonometric angles or functions. However, it doesn't have to be, right? I could have put an x there, I could have put a y, I could put whatever like variable I wanted to, right? Whatever unknown I wanted to. But usually we put theta when we're using trigonometric functions. Okay, now that's good for my triangle right now. Now what I'm going to go ahead and do is I'm going to introduce my trig functions. And I like this dark blue. I'm feeling this one, okay? All right, so here's what I'm going to do. The first one I'm going to talk about is sine. Sine, right? And it sounds weird. S-I-N-E, sine. S-I-N-E. Okay. Now, sine, pronounced sine. Sine is defined in a triangle as a ratio of the opposite side to the hypotenuse. Now, bear with me. I will explain that. Here's my explanation. There was a reason that I put that little theta there. I didn't put it there, and I certainly didn't put it there, because that's the 90-degree angle mark. You leave that alone, okay? It's either going to go there or there. There was no rhyme or reason as to why I chose this one. I just did, okay? But because my theta is there now, that theta is there, that means like this is the angle in question, right? This is the angle that's in custody or something like that, right? This is the one that I'm curious about. I'm really curious about this angle right here. I was like, oh my gosh, I woke up this morning, oh my gosh. That's why I put a theta there, okay? Because I was curious about this angle. So this is the angle I'm investigating, if you will. Okay, so because this is the angle I'm investigating, that means from this angle's point of view, there are 3 sides of this triangle, of course. But this side, if you guys remember from geometry, the longest side of a right triangle is 1,000,000% always going to be called the hypotenuse. And I'm just going to abbreviate that as hyp, H-Y-P, the hypotenuse. That's this side, right? The hypotenuse of the triangle. It's the one that's always on the opposite side, the direct opposite side of the 90-degree angle. Always, 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 no matter what. Okay, so now there are two sides left that I didn't name them yet. Sad face. And in terms of this angle theta, there's a difference between those two sides in terms of this angle theta. And the difference is this. This side with length 3 is touching the angle theta, right? It's one of the sides that actually makes up the angle theta, right? So I'm going to call this side down here, I'm going to call that the adjacent side, meaning it makes up or helps make up the angle theta. I'd really just think of it as it touches the angle theta, right? So this is the adjacent side, A, D, J. That's how I'm going to abbreviate adjacent. Okay, and then the last little one, the third side that we haven't talked about yet is the opposite side, right? And it's the opposite side because it's directly opposite from theta, right? Does that make sense? So this dark blue is always the hypotenuse. The longest side is always the hypotenuse no matter what. Like, don't mess with me, okay? That's it, I promise you, okay? And now, because that side with 3 touches or makes up the angle theta, that means it has to be the adjacent side, right? Because it is definitely adjacent to theta, I promise you, right? And then that just leaves the last side. The opposite side is of course, the opposite side to theta. Now, if I had, in the beginning of this lecture, if I had put theta here, up in this corner, that means that these two guys, opposite and adjacent, they would have flipped, right? That makes sense because then, of course, this side would be touching theta as opposed to this side. But I digress, it doesn't matter. Anyway, so now let's get back to sine. So sine refers to the opposite and the hypotenuse as a ratio. Now, I guess it's very important, and this is one of the hardest things to kind of comprehend, I guess, about trigonometry, is that this sine is like a function. Not even like a function, excuse me. It is a function. It's like when you add, right? Like addition is a function. That's an operation. So maybe function's not the best word, right? But like you add two numbers together. Like that's an operation that you do. Or you subtract, or you multiply, or divide, whatever. But those are operations that you do, right? That word sine, that's not a variable. That's a function. That's something that you do. Like in math, you say, I'm going to take the sine of that side or whatever, of that angle, I guess, right? It's kind of like when you take the square root, a radical, that's an operation that you do, right? It's in some way a function, right? I'm going to take the square root of 100, right? You take the square root of 100 and you get another answer, right? The square root of 100 is 10 and that's your answer because you took the square root of 100. Sine is like the same way. It's like I'm going to take the sine of something, right? An angle most of the time. Sometimes you do it as a ratio of sides if you're talking about the inverse, but I don't care right now. I'm just talking about basic sine. I'm going to take the sine of that angle. Okay? So this isn't like, these aren't just like four variables, S, I, N, and E thrown together. No. Sine is a function. It's kind of like an operation, right? Not the stupid board game operation thing, whatever it is. It's a mathematical operation or function. Okay. So sine is usually defined as, let me put my theta here. I'm going to do sine of theta. And actually, we usually abbreviate sine as just S-I-N, right? Just S-I-N, okay? Maybe I put an arrow or something. Okay. So sine is really just SIN because mathematicians are lazy. And then, well, what are you taking the sine of? Well, you're taking the sine of the angle theta, right? So I need an angle theta in there. I'm taking the sine of theta. Okay, and now what is the sine of theta? Well, sine of theta, sine, and this is, I'm telling you this, sine is always defined as the opposite side divided by the hypotenuse. The hypotenuse, always defined as that. Sine of theta is always the opposite side divided by the hypotenuse. That is like the definition of sine. There's no changing it. There's no ifs, ands, or buts. That's it, right? That's me telling you. I don't expect you to know that from the past. This is brand new. It's like me telling you, hey, man or woman, this is what division is, right? Except now we're doing it with sine. Okay. All right. Another one we have is cosine. We have cosine. Yay. So similar to sine, right? Okay. Oh my gosh, my handwriting is so bad. So cosine is abbreviated as COS for cosine. Okay. So same thing as sine. Cosine is again like another operation. It's a function, right? So I'm going to take the cosine of theta, and the cosine is always defined as the adjacent side, the adjacent side divided by the hypotenuse. It's always the adjacent side divided by the hypotenuse, okay? That's always cosine. And then a third one I have is tangent. I have tangent. And I think you've probably seen the word tangent before in geometry or maybe even outside of math, right? Like that's a word that we sometimes use as humans. Something is tangent to something. But anyway, tangent is always abbreviated as tan. Like you're all going to get tan this summer. Maybe not, actually. So the tangent of theta is always defined as the markers, as the adjacent side divided by the opposite side. The adjacent side divided by the opposite side. I did not. Oh my gosh, I'm having a massive brain fart here. Massive for some reason. Tangent is always defined as the opposite side. The opposite side divided by the adjacent side. I'm sorry. See, this is what happens. This is what happens when you're not in school for over a month. Okay, so tangent is the opposite side divided by the adjacent side, right? Now, these are the three main trig functions: sine, cosine, tangent, okay? Now, there are three other trig functions. They are called the reciprocal trig functions. They are super similar, except they are, you guessed it, reciprocals of the three original, right? The first reciprocal trig function, and let me say this right now, these three right here, these are the ones that I really, really want you to know, okay? These three right here, the main trig functions. Okay, now the first reciprocal trig function is called cosecant. Cosecant. The cosecant is super similar to the sine. I'll connect them, I guess. The cosecant is really similar to the sine, and cosecant is always abbreviated as CSC of theta. The cosecant of angle theta. Okay, now cosecant is defined as the hypotenuse, come on, hypotenuse divided by the opposite, right? So if you notice, sine is opposite divided by hypotenuse. Cosecant is hypotenuse divided by opposite. They flip, right? They are literally reciprocals of each other, right? You flip it. Boom, boom, boom. Okay. Two others I have. The first one will be the secant function. Secant. And secant is always abbreviated as SEC. SEC. And then, of course, that's of theta. The secant of theta. Right? And the secant of theta, that is always defined as the hypotenuse. The hypotenuse divided by the adjacent side. My marker is really running low. Okay. All right. And the secant is really, really similar to the cosine. Cosine and secant are really, really similar to each other. They're just reciprocals of each other, right? Okay. Next, I have the cotangent. That's the very last one, cotangent. And then cotangent is always abbreviated as COT. Cotangent. And then, of course, that is of angle theta. Cotangent of theta. Okay? And then the cotangent is the reciprocal of this guy, tangent. And this is the one that I apologize for my massive brain fart earlier. The cotangent is the adjacent divided by the opposite. The adjacent, pathetic marker. The adjacent divided by the opposite. Okay. Now these are reciprocal functions, right? And they are very confusing, I'm not going to lie. They definitely take time to dive into, to really start to wrap your head around them, okay? So these are the 6 beautiful trig functions that I really wish we would have spent a lot of time with this year. Just didn't work out like that. That's all I have for today. I would maybe recommend watching this video twice. I just threw a lot of information at you that shouldn't be done over video, and I'm sorry. Thank you guys for watching. Marin Pride.